Okay, so this is October 2025, Unit 4 paper. Question number 1 is nitrogen dioxide is produced in the reaction shown. The table shows the results of series of experiments to measure the initial rate of this reaction at 298 Kelvin, right? So they have given you different experiments, like 3 experiments. If you remember, we had 2 types of questions of kinetics. Number one, in which the concentrations are same in both experiments. But in this question for O2, I can say that all the concentrations are different, isn't it? Like if they are same, it should be the same in O2 as well. It would be very easy to find out the order of reaction, but in this question, the concentrations are different. So don't worry about that. First of all, we have to find out the order of reaction with respect to this O2. You know why? Because I can study the change in concentration on the rate. Like what would be the effect on the rate of reaction if the concentration is changed? So I have taken experiment 1 and 2. Okay. I can say the concentration is doubled. I can say the concentration is doubled. So the rate increases by 4. So the rate increases by no. So the rate increases by 2 as well. You know. So 5 and then this is 10. So since when the concentration is doubled, so the rate is also doubled. So this is going to be first order. So O2 is going to be first order. First order. I have 2 options, A and B. Then I have to decide between A and B, which is correct. Now I'm going to find out the order of reaction with respect to NO. So I am going to take an experiment 1 and 3. You can see the concentration is doubled. The concentration is increased by 4 times and the rate increases by 16, isn't it? So the rate increases by 16. 16 into 5 is 80, by the way. So I can say after simplification, it's gonna be like this one. Okay, so then I got this is going to be second order, isn't it? And else you can apply the formula in this one, y2 upon y1 is equal to r2 upon r1, like C2 upon C1, concentration 2 divided by concentration 1 is equal to rate 2 upon rate 1. Okay, so it would be easy for you to find out the order of reaction. This is the sideways calculation. Then question 2 says a series of experiments was carried out to determine the effect of temperature on the rate of reaction between peroxo disulfate ion and iodide ion. A student plotted a graph of ln k against 1 by t and used the gradient of the line of best fit to determine the activation energy, right? EA using the Arrhenius equation. Arrhenius equation is given to you. So I have equated it with the y is equal to mx plus c. So M is the gradient, which is going to be EA over RT. Okay. M is the gradient. So I know that gradient is equal to EA upon RT. Okay. So they have given you the points like, gradient is equal to delta y upon delta x, y2 minus y1 upon x2 minus x1. So what I did, I just took the values and I got the gradient. I'm not supposed to divide it because they have given you the options in this term. Okay. So what I did, I just equated with the gradient that is minus EA upon RT that is equal to this one. And after simplification, I got option A, isn't it? So that's the thing that I have to do in this experiment, in this question basically. Okay. So since I know that this is going to be the gradient and gradient is equal to this one as I have calculated. So then I have to find out activation energy. So this is going to be multiply with this value since temperature is constant. Okay. So I'm not going to include the temperature. Okay. The diagram shows how the lattice energy of magnesium oxide can be calculated. using a Born-Haber cycle. The diagram is not drawn to scale. Yes, I know, because electron affinity is exo and then second electron affinity is endo. When there is an exothermic reaction, so the arrow should be back, like downward. And when the process is endothermic, so the arrow should be upward. But this is not so, right? So they are asking which arrow represents the energy change for a single chemical process. You know, if you remember, in the Born-Haber cycle, we used to say that the delta H of formation is equal to sum of all the values like atomization, ionization, electron affinity, lattice energy. The sum of all the values is equal to the delta H of formation. And delta H of formation is a single step. So they are asking a single process. So of course, this is going to be the delta H of formation. How? Because we know the definition of delta H of formation, that when 1 mole of a compound is formed from its elements, when 1 mole of a compound is formed from its elements in their standard states under standard condition. So Y is the delta HF and this is the single process, which is the sum of all the values. Okay, which is the sum of all the values. Then see this, which arrow represents two energy changes, one exothermic and the other endothermic. So we have only one term, that is electron affinity. Electron affinity, first electron affinity is exothermic and second electron affinity is endothermic. So this is going to be electron affinity. You know how? Because oxygen is neutral and it is going to change into -2. So 0 to -2 means that it has gained an electron and this term is known as electron affinity. Okay. So that's why arrow W is correct. The theoretical value for the lattice energy of MgO is -3795 kilojoules per mole, while the value obtained from the Born-Haber cycle is -3791 kilojoules per mole. You can see the difference, 3795 and this is 91. The difference is 4. Okay. The difference in these two values is small because number one, the magnesium ion is not very polarizing. Remember, the anion is polarizable, not the cation. Basically, the cation polarizes the anion. Remember, that's the concept. Okay. What I'm saying, cation polarizes anion. Okay. So they have written the reverse thing. This is incorrect. Magnesium oxide contains significant covalent character. No, no. Magnesium oxide is an ionic compound. Okay. So it has a major ionic character, not a covalent character. And the oxide ion is not very polarizable. You know why? Basically, it depends on the size of magnesium. It depends on the size of like the cation and also the charge of cation, right? So since the difference is very small, if the difference would be too large, so yes, I would say that the anion is polarizable, but if I can see the difference is very small. So I would say that the oxide ion is not polarizable. That's the only, you can say, possible option that I can select. You know, this question is about sodium chloride. Sodium chloride dissolves in water and they have given you the equation. Since we know the formula for delta H of solution, that is equal to Hyderabad minus Lahore. So hydration minus lattice energy, and hydration, you know, in sodium chloride, we have two ions, that is sodium and chloride. So of course, I would be having the two hydration values, one for sodium, another one for the chloride. Since they gave you the value for the solution, so what I did, I have written the formula delta H of solution is equal to hydration of sodium, then hydration of chloride minus lattice energy, that is the same. Okay. Since they are saying enthalpy change of hydration of chloride, so I have to make it subject, right? So this is my subject. So it remains over there and everything I'm going to shift on the left hand side. So it becomes this one. That's why option A is correct, isn't it? It's very easy. The dissolving of sodium chloride in water is thermodynamically feasible. Thermodynamically feasible means that it's related to Gibbs free energy, not kinetics. Thermodynamically feasible, So, what may be deduced from this statement and the data in part A? So, I would say that, and Gibbs free energy is equal to delta H minus T delta S, like it's related to entropy. Like it's related to what? Entropy, right? So, of course, it's not related to the kinetics because they are not saying it's kinetically stable. Remember, that's the difference in this question. So, if they would be saying kinetically stable, so it's related to activation energy. It's not possible. Again, enthalpy change of hydration is positive. Hydration means cation and an ion they are going to form a bond with water, isn't it? In hydration, the cations and anions are going to form a bond with water. They are being hydrated. So it should be exothermic. So why they are saying positive? Incorrect. The reaction has a positive entropy change of the surrounding. Uh, Positive entropy change of the surrounding means that the reaction should be exothermic, isn't it? The reaction should be exothermic, but the reaction is endothermic. But the reaction is endothermic, as you can see, plus 1.0. If the reaction is endothermic, it's not releasing energy. Of course, the temperature of the surrounding is decreasing. When the temperature of surrounding decreases, so the entropy becomes negative, isn't it? So why they are saying that entropy change of the surrounding is going to be positive? No, this is incorrect. So there is one and only option left, that is D, of course. I would say that D is correct. Isn't it? Make sense, right? Or what are the pH values of these solutions? So they have given you the concentration of nitric acid. Since nitric acid is a stronger acid, and what's the mole ratio between H plus and nitric acid? That is 1:1. If the concentration of nitric acid is 2, so the concentration of H positive ion will always be 2. So I got the concentration of H plus. So what I have to do, I have to put this value in the formula. That is pH is equal to negative log of H plus ion. So I would be getting minus 0.3. It's very simple. In option B, again, you have to find out the pH, but this is going to be barium hydroxide. It's a base. It's an hydroxide, right? Since I know that when barium hydroxide dissociates, so it gives you 2 moles of OH minus ion. They have given you the concentration of barium hydroxide, not the concentration of OH negative ions. So I have to put the mole ratio. So the concentration of OH negative ion would be 0.4, isn't it? Isn't it? But this is the concentration of OH negative ion. I need the concentration of H positive ion to calculate the pH. So I have used this relation. Kw is equal to concentration of H plus into the concentration of OH minus. Then Kw is given, that is this. OH I know that is 0.4. After putting in this equation, I got the concentration of H plus, that is this, and then just I have put this concentration into this formula, then I got 13.6. It's very easy. The thing is that you need to know the formula, like in which question, what formula I am supposed to use. So everything would be very easy. Everything. This is the reason they have given you the Kw value. Okay. So whenever after giving the concentration of base, you have to find out the pH. So you have to use this relation because you don't know the concentration of H plus ion. Okay. So to find out the concentration of H positive ion, we have to use this relation. And after getting the concentration of H positive ion, we can find out the pH. That's why I got 13.6. Again, the same question. The solution formed when sodium hydroxide is mixed with hydrochloric acid. I have found the moles of NaOH, that is 0.01. I have found the mole of HCl, that is 0.020. Then you can see 0.020 is in excess. Okay. After the reaction, it would be remaining, of course. So 0.020 minus 0.010. So the remaining mole of HCl would be 0.010. So the remaining mole of HCl would be 0.010, isn't it? So then I know the moles that is remaining, and then I have to find out the concentration because in the pH formula, we have to find out the in the pH formula, we have to find out the concentration of H plus, not the moles of H plus, right? Not the moles of H plus. So, so how can I find out the concentration? I have to divide the mole by the total volume. So the total volume is 20 and 20, that is 40. So the total volume is 40. I have to convert this 40 into the decimeter cube, and after dividing with this value, I would be getting the concentration, that is 0.25. Okay. After getting the concentration, I have to put it in the pH formula. Then I got 0.6. Okay. Then I got 0.6. Or again, the same question, you have to find out the pH of the solution. So the solution formed when 20 cm cube of 1 mole per dm cube sodium hydroxide is mixed with 40 cm cube of 1 mole per dm cube ethanoic acid. That is a weak acid. Ka is given. Okay. So mole of NaOH, mole of acid. This is going to be ethanoic acid, by the way. Okay. This is going to be ethanoic acid. Of course, this is in excess. I'm going to subtract it to get the remaining mole of acid. Okay. So now, since this is a weak acid, I can't say that the mole ratio between ethanoic acid and H plus would be 1:1 because it partially dissociates. It doesn't give you 100% H positive ions. So how can I apply the mole ratio? No, no, I can't apply the mole ratio just like that. No, that's why they have given you the Ka value. So what I would be doing, uh, first of all, I have to find out the concentration, that is going to be 0.33. I have divided it with the total volume, 20 and 40. So the total volume is 60. After converting this Cm cube into the Dm cube, I got the concentration of acid. After getting the concentration of acid, then I have to use this relation, that is Ka into concentration of acid. This is known relation. Then I got the concentration of H positive ion. Then just I have put that concentration into the pH formula. Then I got 4.8. That's the answer. That's the answer. Okay. Okay, in question 6, the mechanism for the reaction between bromoalkane and hydroxide ions to form alcohol is either SN1 or SN2. If there is a tertiary halogenoalkane, so the mechanism would be SN1. And if there would be a primary halogenoalkane, so the mechanism would be SN2. Simple. The reaction mechanism depends on the stability of the intermediate carbocation formed and the steric hindrance of the halogenoalkane. Steric hindrance is where large groups bonded to the carbon block the attack by the hydroxide ion, which statement is correct for the reactions of primary halogenoalkane. So I told you primary gives you SN2. SN2, you have two options, C and D. Okay, so why SN2? Because primary means that there is only one CH3 and all are hydrogens, and this is going to be Br, let's suppose. So OH can come from the back because there is no steric hindrance. There is no large group attached to that carbon atom, which can block the attack of this hydroxide ion to this partial positive carbon. So that's why option D is correct, because there is a little steric hindrance on that carbon atom. So 2-bromo-octane is chiral because different groups are attached. Chiral center is the one in which 4 different groups are attached. 1, 2, 3, 4. The possible products of nucleophilic substitution of this isomer are this one and this one. These are called enantiomers. Nucleophilic substitution for 2-bromo-octane occurs by both SN1 and SN2 at the same time. Okay. SN1 and SN2 at the same time. Okay. By the way, it's a secondary. By the way, it's a secondary. You can see that. Okay. So bromide ion is substituted by the hydroxide ion. Which best describes the organic product of this reaction? A racemic mixture of the two alcohol enantiomers. Yeah, they are enantiomers, but this is not the reason for this given statement that it can give you both mechanism, SN1 or SN2. Or enantiomer 2 only? No. A mixture containing more of enantiomer 1 than no. Basically, a mixture containing more of enantiomer 2 than enantiomer means that like I had this reactant that was 2-bromo-octane and it has a chiral center, right? So uh, the possible products of nucleophilic substitution of this isomer are, you know, whether it should be this one and whether it should be this one, right? So which best describes the organic product of this reaction? So I would say that enantiomer 2 would be more in this mixture as compared to enantiomer 1. Okay, so that's the answer. The four compounds shown all contain a carbon oxygen double bond. This is aldehyde, this is ketone, this is going to be again, I can say ketone, carboxylic acid, no, ketone, or I can say this is an ester. This is an ester basically, this is going to be H, C double bond OO. This is going to be ester, or this is going to be carboxylic acid, right? So then they are saying which will react with 2,4-DNPH. Of course, only carbonyl compounds can react with 2,4-DNPH. So carbonyl compound is a ketone and an aldehyde. This is not carbonyl, this is not carbonyl. So P and Q is correct, isn't it? Right? Which contain a chiral carbon? Of course, we have to see which one is a chiral center. So this is going to be H, different, CH3, different, and then different. So P is correct, isn't it? It has a chiral center. They both are CH3, it doesn't have any chiral center. Both are CH3, doesn't have any chiral center. Both are CH3, doesn't have any chiral center. So P is correct. Which will react with lithium tetrahydroaluminate, like LiLH4 basically. It's a reducing agent. LiALH4 is a reducing agent. It's a reducing agent. So to produce a secondary alcohol, reducing agent means I have to reduce a ketone into secondary alcohol, isn't it? Because ketone is formed by the oxidation of secondary alcohol. So if I would be reducing ketone, so I would be getting secondary alcohol. So where is a ketone? Of course, Q is a ketone. So when you will be reducing it, it would be giving you secondary alcohol, isn't it? It's very easy. Okay. Uh, Vaccinic acid is a long chain fatty acid found in dairy products such as yogurt. The IUPAC name for vaccinic acid is this one. So I have to select a long carbon chain. This is going to be the long carbon chain, right? This is going to be the long carbon chain in which you can see carboxylic acid and there is a double bond. Okay. Carboxylic acid is the, like I can say, I would prefer it. I would prefer it. And then I have to decide, is this E isomer or a Z isomer? Is this cis or trans? Trans means Z or cis, sorry, trans means E and cis means Z. If this is a cis, I would say this is Z because in this option, they are going to give you the option in terms of E and Z, not in terms of cis and trans. Okay. So by the way, this is trans. This is opposite. Means I would select EE, not ZZ. So we have two options, option A and option C. Okay. So then what I have to do, then what I have to do, um, how many carbon atoms? Of course, in both options, I have oct, means I have 8 carbon atoms, right? Or one, this is 9, this is 10. If I can do this one, you can see this is carboxylic acid. So in between this carbon and this carbon, there is more 9 carbon atoms. Okay, more 9 carbon atoms. So this is 1, so this is 9. And this is going to be 10, and this is 11th carbon. So at 11th carbon, there is a double bond. So yes, option C is because they are saying 11 ene. Ene means double bond. 11 ene means 11 ene means double bond. Which ion is most likely to cause a peak at mass to charge 45 in the mass spectrum? So I have to see the masses. Okay, so 3 carbon atoms means 12 into 3. That is going to be 36, and total hydrogen atoms are 7. So it's going to be at 43, isn't it? If you can see this one, so we have 3 carbon atoms means 36 plus 2 plus 1 plus 4. So total 4 hydrogen atoms, it has to be 40. Or if you can see this one, I have 2 carbon atoms. It is supposed to be 24 plus 5 plus 16. Okay. So how much it is supposed to be? 29 plus 16. Yes. So it's going to be 45. So we have two options. 45, 45, we have two options, B and then D. So they are saying vaccinic acid. In vaccinic acid, where is OH? Where is OH? No, we have carboxylic acid, right? So that's why option B is correct, isn't it? What would you expect to see if samples of vaccinic acid are tested separately with bromine water and phosphorus chloride, PCl5? Since in a vaccinic acid, you can see the presence of double bonds. So the bromine is going to be decolorized by this sample. So I would say decolorizes, decolorizes. I have two options, A and then C. So PCl5, of course, PCl5 reacts with carboxylic acid. So if it would be reacting with a carboxylic acid, of course, it would be giving you misty white fumes of HCl. Okay, so yes, option A is correct. Okay. Which intermolecular forces are present between vaccinic acid molecule? Of course, vaccinic acid is a carboxylic acid. It's a polar molecule. It has a hydrogen bond. Due to its polarity, it has a permanent dipole. And of course, London forces are present everywhere. London forces are present everywhere. So yeah, option D is correct. It's a common sense question. It's a very easy question, you know. Okay, isn't it? So that's it for, I think, section A, right? So I would be uploading section B in the next video. Okay. Thank you.